Hello everyone and welcome to today's webinar. Welcome everyone who joined. I'm very glad you're here. Today we'll talk again about precast detailing and impact. We will be focusing on form slabs, double walls and linked elements today. And of course what we'll be doing today exactly is we will be modeling double walls, and on top of those we'll be doing some form slabs, and we will be adding some linked elements in as well in the form of stairs and whatnot. We will show how to create and edit wall joints for double walls. We will be editing some girders and elements. We will be saving all the elements into the impact database, and of course generating shop drawings and previewing the 3D elements in Impact Project Manager. So with that, let me go ahead to the project manager and show you the model. So this is like the start model. It's been built in the series of webinars. Already what you see here, the leftmost part, is beams columns that were created previously in the first webinar 2 months ago, and the rightmost part about sandwich panels and slabs and solid walls that was created last month. So we already have a model created, more or less, and with that I'll be actually adding some more elements into this model from within the from the basic floor plan of this whole thing. So this is like the AutoCAD view of that, and in here for today's session I've prepared some guidelines so the modeling goes a bit smoother. All right, so let me go ahead and go to the top view, and with that we will be focusing on this area here today. This is just an outline of the for the double walls that I have, and with that I would also like to mention that we will be doing some linked elements as well. So here I have a sketch of stairs that we'll be using in that. What I'll do now is, for the sake of clarity and better snapping onto points, I would just isolate this particular area of the model for us to work on today. Okay, so for your information, in general, for all the other types of elements in impact, so your beams, slabs, walls, columns, and hollow core slabs, you will be using the plan ribbon tab. All right, because it contains all of those components here. For form slabs and double walls, we have separate tabs in the ribbon in AutoCAD. And today we'll start with double walls. And for those double walls, I would like to direct you towards double wall definitions first under double wall section, because here we have the definition of the available double walls in our projects. In my case, there's only one, 200 millimeter thick, with the definition name of DW200, and I'll edit that. In here, what we see is the basic properties, or the basic information about the double wall type that we have. So both the width of panel 1 and panel 2, so the internal and external panels, and we see the total width of the wall. So important information for us. Okay, basically the internal void between panels is created as a calculation of a subtraction from the total width minus the total of the two panels. You can also define the material. So one panel can be, for example, concrete. The other panel can be maybe lightweight concrete or something else entirely. That's all up to you. We can also create end stops, and we will also be able to add end stops at other points during the whole modeling phase, which I will be mentioning if I remember about mentioning that. But yeah, so if you don't want to remember about adding special formwork or something to keep the concrete inside, then you can just model end stops with your double walls as well. And next one is lift and bracing tab. In here, basically, you can define what type of lifts you use, what's the maximum amount of distance between lifts, what's the spacing if there are more than 2 lifts, so 2, 3, 4, What's the default type of a lift? So basically just input the name of whatever lift type you use, whether the lifts need to be rotated, and the number of lifting points, and what type of lift is used depending on the mass of the elements. So for example, we don't have anything defined for one lift. I think it would be not practical in terms of walls. 2 lift points, more stability to that, and we have 2 definitions for max weight of the element. So elements up to 2.5 tons, that's lift number 143, up to 4.5 tons, and that's lift 145. And 4 lifts, that's the second lift type, so 145, but we have 4 lifts for elements over 4.5 ton and less than 8 tons. You also can specify the bracings. So basically, once you place this wall, you brace it to a slab or a foundation of some sort, and you have some rules on how to place the bracing points in the wall as a part of height, or maybe that's a fixed distance. Let's use that part of height. And you also the placement of along the length of that, and the type of the bracing point in a wall that's available to you. That's also here. Next step allows you to specify the reinforcement for the panels. So reinforcement tab is about loose bar reinforcement. So you specify what size of the bars you have, and the horizontal and vertical spacing of those bars, as well as concrete covers. And mesh is the reinforcement for the just mesh reinforcement that you might have and use at your factory. So that's in panel 1 and panel 2. And the way you represent this mesh in the drawings, it can either be as a area, so basically the diagonal line across the view of the element, or as bars. But if you use both the reinforcement and mesh, in the loose bar reinforcement and mesh in your panel, then maybe the bar representation might not be the most clear. With that, you can also specify the layer on which side of the mesh you are using in which view. Next section is the lattice girders. We will be actually moving those around maybe later during the day, and in here you specify the spacing of the type of lattice girder that you use between those two panels. So in my case it's 300 mil, and the maximum allowed distance from edge, or the minimum allowed distance from edge and maximum allowed distance from edge. If you, for example, split a wall at a point, it might so happen that one of the girders will be, for example, closer to the edge than the minimum allowed distance. Then that girder will be marked red for you, so you will know that you can move it about. Okay, so last tab, basically just some overall view settings and some the way the information is stored in the model, and how the properties are set for the lines and blocks of views of the elements. And that's it. So I'm going to accept that, as well as I'm going to accept the definition, either go out of the window. And with that, let us actually start modeling. So what I'll do now is I will click on the start point, and I will specify a clearance at the start of the element. So I'll set it to 10 millimeters. You will be always asked about that while actually creating elements. So what happened here, once I zoom that out, so from the point that I clicked as the origin point of the wall, you see this large red circle. This basically gives you an immediate idea of the allowed size of the element. This is the max size of the element that you can get still within the acceptable range that's set in your project settings. So basically you can produce that, and you can lift that element out of your table or form. If we exceed that, the software won't stop us, but the element will be marked red, that it's too big and it needs to be split at a later date. So let me go ahead and play around with that a bit for you. So first things first, while pressing certain letters on keyboard, you can change the alignment of a wall. So for example, if I go right, you can see the alignment has been changed. If I go L, I am now aligned to the other side of that white line that I've drafted before, and C is for center. And we'll go center here for this particular spot. What you can also notice is the arrow and the text unmarked, and that shows you the internal side, or the side which you can brace. Yeah, well, basically internal side of a double wall. So we can switch that with an S and a spacebar on the keyboard. So let's actually do that here like this. Okay, and what I'll do now here, I can go ahead and click here, and you see the circle, the red circle actually moves about once I click through points, right? One other thing, you can see that the joint between those two walls is automatically created. If I don't like the alignment of that joint, I can change the priority by selecting this option or pressing I on the keyboard, and you can see the priority change. So basically which side, well, which wall covers which end face of a panel from which side, and like that. But now I don't have to click at every single point like this. I can just go straight to the end, straight to the end, and straight to the end. Yeah. One other thing, you can also press P as properties. And here you can specify, for example, the height of the wall. For us, it will be 3000. It's going to be fine. And I'm going to accept that. And I'm going to click at the end. And I'm going to press space. And now I'm asked about the clearance at the end of the set of those double walls that we have. So I'll press space or rather enter. And I immediately see that 3 walls, which are very long, have not been gave out the warning that they're too big. Okay, and they're too big. If they are too big, then it's just a matter of actually splitting them. And to split them, we use this option. So let me select a wall, clearance between the walls, and click like that. And walls are now split and divided, lifts are added, all good. So I'll do the same for those walls, split, split, okay, and the last one, then split and split, enter. Everything's green, everything's okay. There's no red girders, which means that the girders are placed correctly. We didn't split anything in a silly place. Let's actually finish up with the other walls as well. So let me create those walls, and for those we can, for example, go here, make it smaller here. I'll explain why I'm doing that a bit later. Clearance at end, which is good. And last walls, again, start and end like that, and that's good. And with that, I can also copy the walls with standard AutoCAD commands, so I don't have to draft everything manually. And I can also use a mirror tool, so I can copy those walls to the other side, right? But maybe before I do that, before I copy those, let's focus on actually editing those walls slightly. So what I mean by that, for example, here, that's the start point and my end point of the whole placement of the external double walls. With that, you can see that the joint was not properly created. It doesn't do that automatically once, because that's basically start point, end point. For the intermediate clicks, so once you have this one and this one as a start and end, then the software actually knows that it's a corner, so it does that. But that doesn't bother us too much. We can quickly fix that. So let me just have a look at this end. Okay, those panels are on top, so let's do that. I can now easily edit the length of the panels. So let's do that. There is an option here available, which will allow me to edit the panel lengths. So let's do that for this. Now, let's actually edit both panels. Move it here, and let's actually move that again, both panels. What I'll do here is just move that 10 millimeters so we have the nice spacing. And you can see that the girders move as well. So that's good. What I'll do now, I'll just extend the second panel, so this one, and I'll move here. And I just moved one panel. What I'll do here, I'll move now this panel. So this panel 1, move it to here. Oops, I wasn't supposed to do that. I was supposed to select this one and actually move it just to this edge. Yes, so that's good. And now just this one, like that, and move that by 10 mil back. And now we have a nice little connection. And of course, if for some reason I need to change the priority of that joint as well, there's an option here. I can just select that and it will switch that priority for me for this wall. So even though it's not like an automatically created joint, the software still knows that, yeah, switch panels, basically. Okay, with that, let me go ahead and, for example, create a connection between this wall and this wall, because this requires a T connection between those. So let's tool for that. Let me select those two walls, like so. And I have a bunch of options here. So it automatically detects that we have a T connection between double walls, and we can either create a slit, we can create an open hole throughout both panels, or we can, add a U-bar and a slit for different type of concreting, different type of connection. For us, I'll just use a slit and not make it a cut through the whole height of the panel. So it's just going to be a slit in a wall, which we'll see. So I'm just going to accept that, and there's that slit. Okay, one thing I forgot to do, I actually wanted another wall here, like so, and that's going to be here. Okay, that's perfect. And for that, simply put, let's actually do another T connection here very quickly. Just press space to do that, to accept that, and another one here that will allow me to get this connection going. Yep, that's done. So as you can see, that's very fast, very quick, and with that quickness, I'd like to also follow that up with just being able to mirror some walls. So I'm going to do that. Click, click, like that. My walls are now marked for mirroring. I'll just need to find the actually the midpoint of my line here. Select that, and walls are done. Basically, my double walls are now done. My stairs are nicely aligned, and that's all good. With that, once I'm done with this, basically, I can also go ahead and, for example, generate braces. So I'll just do that on, for example, this wall, and I'll get an information about the braces, bracing anchors if there are clashing braces between elements, base elevation and whatnot, as well as the diameter of the brace, as well as the angle. I'll just accept that, and immediately I can see that there has been a brace created. So let me go to the 3D view, and there's a brace attached to a brace point in that. There's also multiple girders in the visible in 3D view. Before we move further, how to actually move the girders about. Okay, so in order to do that, I can click on this tool. I can select a wall. So for example, let me select this one, and I can move a girder space, and I can move that to a previous or next location. But you see it gets marked red once I move it, because it has been placed in that nice sweet spot with between minimum and maximum distance from the edge of the double wall. And with this option, I'm moving it by 300 mil, which is the spacing of the girders that we have, and we're moving it basically too far, too close, and so we don't really need to change the position of that. But if need be, then of course you can add that. You can move that. If you need to delete a girder, that's how you do it, and you can create a new one, specify location, and basically it will place it at that nice little spacing that you have. And let's exit and exit, and that's it. That's how you do it. What I will do is I will also create openings, because that might be of interest to you. So let's actually create some openings. There's a couple of different ways to create openings. There's rectangular openings here, there's circular openings here, there's window holes and door holes. So what I'll do is I clicked on the door opening, I clicked on this wall, and I'll basically just start placing an opening of some dimension, because it doesn't really matter what the dimension is on screen, because you can still fix it here. For example, make it 2000, right? So that's good. And I can specify the spacing and then the exact placement of that. If I need to add reinforcement, if I need to cut meshes inside that, and whatnot. If I want to add an end stop, I can, for example, add an end stop, the small one, for example, and that's it. Or maybe 130 might be better, and let's accept that. And see, here we have an opening. If I rotate that, just be advised that that doesn't immediately update the refresh the element that the opening is in. So the girders have not been cut, but or not. Either when we reopen the drawing, they will be automatically cut, or when we open the not the drawing but model, or when we actually create drawings. There you will have the girders cut. Same thing if we actually go for the window openings. Select this wall. Oops, I didn't select the wall. Okay, first corner here, like that. Let's go 150. Okay, distance from floor and 900, which will be perfect. And let's maybe add another end stop as well. Okay, and this is our opening. That should easily cut the meshes later when we do that. Okay, so how do you now actually get drawings out of it or save it? Because all the elements are unmarked. The process is a bit different than with other elements in Impact. We actually have to set the marks manually for our elements. So I'm going to select the walls. That works for double walls. And with that, the double walls will be saved with a prefix that we have set in the element settings. I start with element mark. It can be 1, draw order or selection order. That basically determines what numbering order is placed upon the elements. And as you can see, we have different wall types. Yeah, a bunch of those. I don't think we have 21. I mean, we might have actually 21 elements. Yeah, so that's it. Those are the walls for us. I didn't bother creating like openings between rooms and whatnot, because this would take too much time in this presentation. There's really no need to do that. But yeah, it's done, it's saved. So now we can actually go ahead and create drawings for us in this instance. This will automatically also, while creating the drawings, those double walls will actually be saved to the database. That's when they are actually saved in the database, once we actually create drawings out of those. So there's 23 drawings. That should be fairly quick for us. Yeah, I'll just wait a bit until that's done. Those will be simple drawings with nice layouts, but very nice, very easy for you to get the drawings out, basically. So we already have some layout prepared, so you can get up and running with the drawings for double walls very fast. You'll get the views for the panel 1, panel 2. You might get a 3D view as well for the girders. if need be, like 3D views of the reinforcement as well. So yeah, so let's just wait a short while more. You basically see it live, how long it takes to create this many walls. That takes a bit. It's 23 drawings to get out of. That maybe was too much to demo at once, but still. With that said, once that's done, we will actually move to the form slabs. And for form slabs, basically the placement and whatnot, we'll play around with form slabs, moving the girders around slightly, maybe slightly editing the reinforcement, but not much. Yeah. Also, I'll show you how to set the elevation of the form slabs as well. Yeah. General stuff. Yeah, definitely I shouldn't have clicked on all 23 walls, but still. Some of the walls will probably be already saved to the database, so I'll just refresh the model for us. Yeah, well, since they're almost done, So let me go back to AutoCAD. Yeah, it's already done. So if I go back to that model we have, if I update that, refresh that again. Yeah, let's refresh that, and there's the final wall. Okay, so there's our double walls. Oh, I think yeah, I will probably have to fix that, but that's not a problem. We can just move over, change the elements later. Oh yes, I forgot. I was supposed to move this the alignment of this wall. Yeah, that should have been inside this wall. I forgot to change the placement. That's fine. That's fine for the demonstration. Yeah, if I go properties, I don't think we can change that now. No, we don't. So that doesn't matter. That doesn't matter. It'll just look worse in the in the preview. That doesn't matter. I can move the whole building now to make it look nicer, but let's not waste time on that. Okay, so with that done, actually, let's move to the form slab. Oh, yeah, drawings. I've created drawings and I haven't shown them to you. Okay, so let's actually open up a drawing. So let's open up, for example, this wall. This is a simple one. Basically, all the drawings for the walls are created as well. You see something loading on screen, and with that, I go to drawing, and I get a nice little view of the wall. I get the location of our girders, the exact positions of those as well, specified online every 300, like on a single line with continuous dimension, every 300 as set with our properties. We've got the size of the elements as well, the rebar for panel 1 that has been defined, so your horizontal and vertical rebar, and just the mesh for panel number 2. So it's here, it's visible. Yeah. Basically, you also get some mesh for reinforcement for the reinforcement in the first panel, and again a bunch of data about the wall itself. All right, and a also 3D preview with the with the girders. You can of course refresh and regenerate like reinforcement in those panels. I won't do that for now because it took a bit longer than I wanted, so we still need to do the form slabs. Right, so form slabs. How do we do form slabs? Well, form slabs are pretty fast. Not pretty fast, very fast. Let's go to the form slab window. As was the case for the double walls, let's first start off with the definition. I have a bunch of form slabs defined, standard form slabs. You can also have pre-stressed form slabs. For those, I have no definitions right now in the project. And I have a couple of definitions of form slabs. So that's like a 550 mil concrete layer on the bottom with mesh and some fixed reinforcement as well. So in general, basically very similar to double wall, we have all our specifications available here. So our max width allowed for our form slabs, the thickness of the form slab itself, and the slab thickness overall. So basically how much concrete you not how much concrete you pour over the form slab, but rather how thick the form slab is with the concrete poured over it. Anyway, lifts basically automatically placed in those form slabs as well, depending of course on the mass of elements. The reinforcement specification, if we want the reinforcement just in one direction, or so basically longitudinally. I'm sorry. Getting colder in Poland, my throat is getting sore. So because it's getting all dry. Now, so reinforcement in the main direction of our slab, so basically longitudinally. The secondary direction, which is perpendicular to that, so basically your transverse reinforcement, you can specify if you want that, and your covers and where the reinforcement is, so which is on the bottom of the slab. Bend bars, if you include those, and how do you measure those, you can add those as well to the slab if something that needs to extend out of the slab. The mesh, so what type of mesh you use, basically the cover of that reinforcement, etc., and where is it placed. Lattice girders used for the form slabs, so as was the case for double walls, you have your lattice girders as well for your slabs. And the distribution, that's basic distribution, so basically the spacing of those girders and spacing that's allowed in bigger elements, tighter spacing. Of course, you can also specify a shape of an edge. Here you don't get a preview, but you can specify chamfers and where those chamfers are on the bottom or top or wherever. And if you want, you can also attach insulation. I have none defined for this particular slab, so I can't add insulation, but you could if you were so inclined. And MISC settings, so various different settings on the slabs, as well as the prefixes as well for those. Let me accept that, and we will be using just this primary slab. Of course, this one, for example, is with insulation. It has some definition of that, polystyrene insulation, and the thickness of that, and how far off from the girders it is actually placed. So let me close that out, accept that. With that, let's go ahead and actually place the slabs. So let's drag the slab like so. Here we get the initial placement options for the slabs. So we can select the type of slab. So the first one that we used, as was just an error because some settings here by default something changed basically. I had some different values set that are not compatible with this, but no, let's not worry about that. Let's go 3000 for the elevation of that, because I want to place my form slabs on top of my walls, and then we'll align the stairs along with that. Right, the mesh, so if you wanted to use a different mesh here, we could specify that. If you wanted to change the reinforcement to something else, we could specify that here. If we wanted a different lattice girder and spacing for those, again, that is where you set it. What you don't set is the secondary reinforcement. That needs to be set in the definition. Or rather, you could, you can't really do the definition in here. Let's not do bended bars, and I'm just going to accept that. what I'm gonna do is I'm gonna place the slabs by the window. I'm just gonna select that and go ahead and do it this way. I'm going to do a support edge, not here, but on the other direction. So step to next. So this is going to be my support edge. This next one is going to be 0, and this one is going to be 80, like that. No slope, and let's actually rotate that by 90 degrees. Oops. Yep. And that's that. And let me choose the start point like that. And this slab will be the cut one. I'm going to apply this. And this is my placement. I can mirror that to the other side, which we'll be doing later. I can also copy those slabs as well with a Ctrl+C. Wrong, not here, bad copy. Actually, let's edit that, and let's maybe actually copy that on this point. Oh, wrong. All right, I'll probably just mirror that then. Yeah, I can mirror that. That's going to be form slab. Let's mirror the form slab. Yep. I'll just move that to align everything correctly, because I see that it's not properly aligned. Yep. So that's pretty fast and easy. And of course, if we need, we can of course recreate those slabs here, or maybe we can change direction of those slabs. But yeah, let's try and do that. So if, for example, you need to change slab direction, you can of course do that. Yep, like that. Of course, you don't have to do it this way. You can just extend your slabs, for example, to the ends of panels, and then just have 0 on support edge. But what I'll do here, this is going to be 0. This is not. Step to next, 80. Step to next, and 0. Yeah. Right, no slope. And for example, we can leave it as like this. And this actually makes it fit 2 slabs perfectly with no cuts in this direction. And with this done, let me go ahead and actually add the last set of slabs here, just so you can see how fast it is and how easy it is. Yeah, same type of slab, except what I'm going to do, I'm going to click through here. And change that to here. And I'm going to make that an 80. Skip to next. This one is going to be 0. Step to next. It's going to be an 80. And next and 0. So that's just basically the end cap as well. So that's the edges that you had defined here. They have no difference for me in this case, but just so you know, you can change that. And like that. Maybe let's change that to here. So 2 cut slabs, but previews, yeah, and apply. Yep. So that's what I have now here. Those are my form slabs. If need be, if you need to create an opening of some sort, you can use this tool, draw hole, right? And you can specify if that's a rectangular hole, polygonal, or circular. You could select an object. You can specify if you want to cut the mesh, or if you want to keep the mesh in your opening, if you want to do some filling and whatnot, how it's dimensioned, how it's annotated. If you want to add an end stop, for example, we can add an end stop, maybe this one, a bigger one. If you want to cut lattice girders or not. So all of those options available. So maybe let's go and add that in this slab, like that. And that's it. What I need to do now is I need to edit this slab, double click, select add here, and select all. Basically the software will find the find any openings that you've created within the outline of the element, and will add that automatically to the content of the element. So as you can see, the girders were cut, there's an opening and whatnot. In here we don't need an opening, we just need a solid floor, and that's it. That's basically how you play around with the form slabs and how to create openings. Of course, there's a bunch of different options: edit length, rotate slab, save it, trim and extend the slab, like to have it at an angle, or other options. So it's all there. What I'll do now is basically I'll mirror those slabs for us again. Select the slabs that I want mirrored, like that, and like that, and those are the only slabs that I want mirrored. Select the midpoint of here, should be good. Let's actually undo that because I didn't select the right angle. Yep. That's pretty fast. And midpoint. So if you make an error, it is very it's very easy to actually remedy the error, like so. And let's not delete the other elements. And that's fast. We already have a multitude of form slabs available. With that, let me go ahead and actually, in this instance, actually let's set element marks as well, because you need to set those element marks for form slabs. So I'll just select that. It will find which form slabs are identical, which are not, and yeah, that's it for draw order. So those elements, those slabs are now done, and now I can save those slabs. The difference between form slabs and double walls is I don't have to actually create the drawings to save them to database. I can just save them, and once they're saved, they will be visible in the project manager. So we'll have a preview of that as well, and they're done. So if I go into the project manager and refresh that, and we have form slabs with openings. Those have an improper level, but easy to fix. Yep, definitely easier to fix. So we'll just move those by 200 up. So that's also very good to be able to check that. And with that, I'll just move to the front view and check the slabs that are too low. So those are the slabs that we want to move, and those as well. What I'll do is move them displacement. So we're going to use 0 displacement, 0 here, and 200 to the top, and that's perfect. So all our slabs are now at a proper level. Yep, they are good. Okay, our slabs are there. Oh, something happened improperly. As see, didn't move my slabs all where I wanted to. Yep, now it's good. Some error in inputs on my part. Not an issue. Okay. So that's top view. That's those are our slabs. I can also make sure that they have proper elevations in there, so I can just save them to the database again. And that's it. Once they're done, let us create maybe 2 drawings, so it will be pretty fast. And instead of just going over and waiting quite a while for the for the drawings to get generated. So again, let's select maybe this one, the FS1, and let's select maybe one of the cut ones as well. So maybe this one, small slab, right? So just 2 drawings. Let's just accept that. It should be pretty fast. Just 2 drawings for us to have a look at. Yep, that's done. So as you see, I'm a bit faster. Let's open this one. Let's open this one. That's the first one, and that's the second one. That's already done, and that's perfect. Okay, so let's go to the drawing view. We have a 3D view. We have a reinforcement display. We have our basically our girders also set up, as well as a reinforcement view in this window. And for the other drawing, maybe I'll keep it in the model view just for it to be a bit clearer on the drawing without printing that. So darker background, more clarity. So you have the girders here, basically some additional reinforcement, red reinforcement, yellow girders. Girders are cut here, maybe warrants moving reinforcement a bit, and we have those girders as well. Now, if need be, of course, we can, for example, draw a lattice girder, and we can specify the type of lattice girder that is. Let's maybe do this one, and we can specify that from here to here, and have that maybe not in the 3D view. Maybe let's not do that in 3D view, but let's do that in the 2D view. And we can add that girder here and maybe add the description of it here. And that's that. So we can of course add those girders, and that they will be added to the schedule as well. So you can add girders here as well, edit those, save them to material takeoffs. Of course, for both double walls and form slabs, you can export the data format to Unitechnic, so and other machine formats, so they can be input into machines, and your meshes can be welded and bent as they are required. So again, go back to the drawing, and we have our reinforcement. If I refresh that girder, it would be there, and that's that reinforcement as well. Now back to form plan or floor plan. We do have stairs here. How to do stairs? Those we do from the plan tab, and we use linked elements. What I will do is I will use the draw stair command, which will allow the software to take the geometry from the model, which I want to be total height 3200, thickness maybe 1500. I will need to take this geometry in. So the whole outline like that, and select that, get the insertion point, specify rotation, and whoop, that's too big, 150. Yep. And that's how the stairs can be automatically generated from the 2D view. What I want to do is I want to make sure about the geometry that it's set. So I want to also create a bar mark for my geometry. Let's call it ST1. That's going to be my element mark. I'm going to accept that. Right, that's going to be ST1, and those are the properties of that. Height of steps 24. They might be too, yeah, they're probably too tall, but for the sake of demonstration, no, they're definitely too tall, but for the sake of demonstration they should be fine. So with that, let's accept that and specify the placement of the element mark. And if I want to, I can actually insert more stairs like this in the model. I can rotate those as well, so maybe different different placement of that space, accept that, and accept the placement. Oops, I don't need any more of that. So those are my linked elements. Now I can save them, all the linked elements, to the database. Now if I go to the model, let's refresh that. That should actually raise all my, yep, my slabs have been raised, and my my stairs have been as well. That's an error. I probably should have made that 3000 for the top, because the last step was raised. So just a matter of actually that's good, because we still have concrete pour over on that, so my levels are actually good. Okay, so that's good. Here, of course, this is a stairway to nowhere really, so let's not worry too much about that. But yeah, so that's how you create linked elements in terms of stairs. In terms of other linked elements, like for example here, that's a concrete footer for the column. I've created that previously. The way I created that basically is I've created a geometry in AutoCAD. Let me just show you. With end object isolation. And that's the F1 footer. Name is overlapping with the column here, but that's a footer. Basically, that's just the box geometry for the for that footer, and you can, using this option, create link. You can actually specify a mark for this particular element in the model, and once you have it, once the element is saved actually as F1, you can reuse that element in your model. So yeah, you can use that linked element as a column base for the elements here. So just this one, you can copy that over, and software also know the properties of that, like the volume and mass and area, and you can create drawings out of it as well. And with the let's go back to the FS1. Basically, you have a bunch of tools in the element tab that allow you to add reinforcement to your drawings. So you can so since, for example, if you have like one pad footing as a linked element, then you can just create one drawing, add reinforcement to that, and you will be able to reuse that throughout the project all over. And yeah, that's it. That's how you can do that. So you can draw in bars, you can draw in meshes, you can draw bent bars and whatnot. So a multitude of options for you to choose from in terms of how to create and edit linked elements as well. Okay, so I think that would be a wrap. So basically, yeah, let me go ahead back to the model. Let's draw solid, include reinforcement, include casting material. That should actually include that. Didn't. Yeah. Let's regenerate that. Let's actually regenerate the drawing. It should actually add that 16 rebar found. That's good. Okay. Yeah. So basically, this is the type of drawings that you get. So what we've done today, again, let's go back to that presentation of ours. So we did modeling, double walls, form slabs, how to edit elements, how to add connections between, how to create joints between walls. We did edit the girders in a wall. We did edit girders in the form slabs as well. We saved all the elements to the impact database. We did linked elements as well, stairs, and we've discussed other linked elements as well. And we've of course generated shop drawings of various elements. And those the model that we've created is visible here. So we've added a bunch of double walls, form slabs. We've added, as well as mentioned, linked elements. We've created those drawings. So for our double walls, Again, we get a bunch of details automatically scaled to the drawing size, so it fits nicely and looks nicely. There's the form slab drawings as well, which look very similar to the double walls, really, which are automatically again scaled for you with a lot of descriptions, a lot of labeling and dimensioning as well. So all fits and all good and all nice. With that, that would be a wrap. That's all the general workflow features in precast detailing in AutoCAD for Impact 17. And that would be it from me. I would like to thank you for your attention. With that, I would also like to invite you all to our Strusoft LinkedIn page, our Strusoft YouTube channel, where we have a bunch more info available, more webinars on different topics, on the Revit version of AutoCAD, on the production suite of the Impact, and other software from our company. And we would also like to invite you to strusoft.com and our wiki for Impact, so you can learn more about Impact in general. Okay, and again, thank you for your attention, and hopefully see you in the next webinar.